Okay, in this next video we want to look at the idea of problem solving, and we're just going to go back through some of the dimensional analysis we've done in this chapter, some of the significant figures we've done in this chapter, and just talk general and more broad case of how to go about solving a problem, making sure we're following some basic steps, some basic ways of writing things so that we can be as clear in communicating our problem solving strategy and be more successful as we go about problem solving. One of the most important aspects to doing problem solving well throughout this course is lots of practice. You've got to practice and practice and practice these kind of things on a daily basis to really get good at the problem solving method and to make sure that you are mastering each of the concepts. Some of the guidelines we're about to discuss, though, will be helpful as you set up an individual problem. When you're thinking about problem solving, you should think about four basic questions. Where do we want to go with this problem? What are we trying to find? What is the answer we are looking for? What do we know? What is the given data? So if we're looking at each of this first question, what is the answer we're trying to find? What do we know? What is the given data? How do we get there? What methods will we use? What conversion factors? What process will we follow to get there? And then finally, looking at our results. Do our results make sense? Does it give us a reasonable answer? This is one of the most commonly skipped steps by students, and this step, if you'll take the time to do it every time, will save you from a lot of mistakes. You can clearly see if it's asking for the number of meters in 5 kilometers, and if you end up with 0.005 meters in 5 kilometers, and you know that a kilometer is a lot bigger than a meter, so you should have a lot more of the meters, that answer doesn't make any sense. You can quickly find mistakes that you have made. Looking at does this answer make sense is a huge step that will save you from a lot of errors as you go through problem solving. Let's think about unit conversions. We've been doing dimensional analysis throughout this chapter, and we want to make sure that we're doing those correctly. If I were doing a dimensional analysis problem, here's the basic steps I would follow. First, with converting from one unit to another, we need conversion factors, equivalent statements, ratios between the two units. So I would first list out all the data I know and all the appropriate conversion factors that exist with data. Part of this will also be making sure I know and have memorized the basic prefixes that we use so that I know the relationship of all of those basic conversion factors. Second, choose the appropriate conversion factor that we want to go in the direction of the change that we want to make. Making sure that the units we want to get rid of are being canceled in each step. Multiply the quantity to be converted by the conversion factor to give the quantity that you desire. And this big, very important last step, we're now learning significant figures, do the number of significant figures in the answer. Are they appropriate for the least precise piece of data that we worked with in the problem? Here's an example problem that we can walk through. It involves a unit conversion, not our basic metric unit conversions, but a more complicated conversion that we want to look through. So let's walk through the basic steps as if I were to approach this problem. Here's how I would write it out. Here's how I would do it step by step. And if you'll follow the same kind of system, I can clearly see what you're doing, how you're writing it out, and give you credit for all the things that you're doing right, and really see if you are making mistakes, where those mistakes are coming. So the first thing I would do is read the problem and underline each important piece of data. So you're throwing a pizza party for 15 people. That's going to be important. You figure each person will eat 4 slices. We want to know how much is it going to cost. We call the pizza place. Each pizza will cost $14.78. Another important piece. There's 12 slices per pizza. We want to figure out, do we have enough money? How much money do we need to do this? So I'm going to list out all of this important data. I know I need 15 people. I know that I'm going to have 4 slices for every one person. That's going to be one conversion factor. I'm looking for how many dollars is this going to cost. I know that one pizza is $14.78, $14.78, and I know that one pizza is 12 slices. So I'm looking for the amount of money. I'm going to write my starting value here, 15 people. This isn't a conversion factor. This is the one piece of information that is just a given value. I want to convert that. One thing that can be really helpful is to sort of make a plan of the conversions you're going to do. I'm going to go people to slices to pizzas to dollars. So the first one, I want to get rid of people. I want to find slices. So one person, 4 slices. Second conversion factor, I want to get rid of slices and go to pizzas. 12 slices for every 1 pizza. Finally, I want to go pizza to dollars. 1 pizza, $14.78. So, check to make sure I've done this correct. 15 people, people cancel. Slices cancel, pizzas cancel. I'm going to get dollars. Now I'm going to take my calculator, multiply by the things on top. So 15 times 4 times 14.78, and the whole thing divided by 12. It's going to be, in this case that I'm looking at, it's going to be $73.90. Now, the next thing that I would want to look at is significant figures. What makes the most sense significant figure-wise? Now, if you look at this, 1 significant figure from 4 slices, the rest of this is pretty exact. They're exactly 12 slices in a pizza. A pizza is exactly $14.78. So you could make a justification to round it to 2 or 1 significant figure. But in this case, with the money value is going to be my least precise value. It's going to be the value that I would probably stick with. I'd probably leave this as $17.73.90. So the last thing I want to do is check to make sure this answer makes sense. Does it make sense that we'd have about $73.90 worth of pizza? Well, 15 people, 4 slices each, that's 60 slices. That's going to end up being 5 pizzas. 5 pizzas at about $15 a piece. $73 seems very reasonable. So this answer makes a lot of sense. So this is just one way of going about solving the problem. The more work that you show, the better off you're going to be.